Hello, welcome to this lecture. So in this lecture, we are going to discuss about the steel beam design, and this is the content that we are going to discuss in this lecture. So now talking about the beam. Now, first we have to understand what is beam. Well, beam can be defined as a structural element uh, which uh, which carry the load transversely, primarily, or in more detail, we can look at this diagram. Well, in the diagram, you can see this is a beam section, and along the length of beam, the axis which is passing through the centroid, it is called the longitudinal axis, and the axis which is perpendicular to the longitudinal axis is called transverse axis. So basically, the load on the beam, we generally we say that the load will be along the transverse axis. So that is why we say that beam is a structural element which supports the load transversely. But it is not like it will always carry load transversely. Vertically, the load may be inclined load also. In that case, some component of this load, say this is a P load, in this case, some component of the load will be passing through the transverse axis, and some component of this P load will be passing through the longitudinal axis, or it will be acting along the longitudinal axis. Now, talking about the beam, the beam is having much complex load carrying action uh, other than the structural elements such as truss and cables. Well, why we are saying this? Because in case of truss or in case of cables, the members that we use in the truss or cables, they are primarily used to resist the axial load. Now, axial load means the load which is passing along the longitudinal axis. So in this case, if we pass load along the longitudinal axis like this, in that case, this beam will behave like a column. But in case of beam, what we are doing is we are applying load transversely in this direction. So that is why it is a little more complex, because the effect of load when we apply it along the transverse axis is very complex. It will have different types of effect that we will discuss in the upcoming slides. And that is why we are saying that the load carrying mechanism and the carrying action is very much complex as compared to the members used in the trusses or cables. And basically, the load which it is supporting, it is generally transferred primarily by the two effects. One is called the bending and the other one is called shear. So whenever it is supporting a vertical load, this beam is supporting vertical load, then the effect of load will be primarily bending and shear. We will try to understand this in more detail in the next slides. So in the diagram, you can see there are uh, photos of the beam. So beams are basically the horizontal member which are generally supported on column or maybe supported on the beams also. So the beams which are supporting on the beams, they are sometimes called the secondary beams, and the beam which is supporting on the column or on the wall, main wall, then those beams are called the main beams. So there are different types of beams based on the location. So wherever we use beams, it may have different notations. For example, in case of floor beams, well, a major beam of a floor system, usually supporting joists in buildings, transverse beam in bridge floors. So floor beams are basically the beams which are generally used to support the floors. Now, these floors may be of bridge floor, or maybe the floor of a building. Similarly, there is another type of beam which is called girder. Well, girder, as the name suggests, this is actually the main beam again, and the main beam which is being used in the building, it may be termed as girder or floor beam. But in case of floor beam, there may be a beam which may be a secondary beam. So basically, in a building, if there are beams, like this is the column. So to support, if the beam is resting on the column, then this may be called the floor beam. Similarly, if the beam is resting on the beams, in that case, it may be called the secondary beam or the joists or secondary beam. And generally, these main beams which are supporting on the column, they are called floor beams, or sometimes they may be called as girder. Basically, when they are carrying a very heavy load, in that case, we call it a girder. Similarly, to support this beam and this beam and this beam, if we provide column here, if we provide column here to supports, sorry, if we run a beam like this, so this beam can be secondary beam if it is supporting on these beams. Like in that case, if I cut the section, then this beam will look like this one, and it will be supporting on this beam, this one. Okay, so like floor system will be like this one. So this floor is first resting on this beam, and this beam may be supporting on the side beams, like this one or this one. I will be showing you the photos of these floor beams girder in the next slides. Similarly, then we have gird. Well, this gird is used in the industrial building. Again, I will be showing you this gird beam. Generally, we use this on the wall cladding to support the facade. Then we have joist. As I discussed, joist is a secondary beam. Then we have lintel beam. Lintel beam generally we provide on the door opening or window opening. Then other beams, maybe purlin. Purlin is also a kind of beam. Generally, we use this purlin in the truss. Again, I will be showing you the diagram. All these beams I will be showing you in the diagram in the next slide. Then rafter. Rafter is again a kind of beam which is being used in the truss. Then we have spandrel beam. Generally, spandrel beam is called, it is a beam which is generally provided on the outside perimeter of the building. Like on any floor, if we are providing the beam on the outside perimeter, then that beam will be called as spandrel beam. Then we have stringer beam. Stringer beam is generally provided in the staircase. Well, this is again a longitudinal beam which is generally provided to support the steps of the stairs, or in case of bridges, like if bridge is like this one, something like this one, if bridge is like this, so in that case this will be the floor. So to support the floor, a central beam may run like this, and this beam ultimately will be supported by these beams. We can provide another beams. So these beams will be the main beams, and this longitudinal beam can be called as stringer beam, generally in case of bridge. So now you can see in the photo, these are the main beam, and the beams which are supporting this one, all these beams which are supporting on the main beams, they may be termed as the joist. Similarly, in this photo also you can see the outer beam, like this one is the outer beam. Outer beam is called as spandrel beam. Similarly, the beam which is supporting on the column, they may be called as the main beam. And sometimes floor beams are termed for the secondary and main beam as well. So basically this classification is based on the location of the beam. Now in this kind of structure, this is basically a example of industrial building. So in this case, you can see on the outer side, these beams which are running like this. So these beams are called the girth. Similarly, uh, the beam which is using like this, you can see here, this beam, all these beams are the purlin. Similarly, this beam which is being used like this one is rafter. Okay. Now in the fourth photo, you can see these are the steps, and to support these steps, a beam is running centrally, longitudinally. So this beam will be called, in this case, will be stringer beam. Okay. So this is basically the classification or types of beam based on the location. Well, beams may be classified based on the support system also, like on the end, how they are being supported. And in that case, beam may be termed as a simple beam. Simple beam can be uh, like this one, which is simply resting on the supports. Similarly, if a beam is a fixed beam notation is like this one. So in that case, it is providing vertical reaction, it is providing horizontal reaction, and also it is preventing the rotation. So in this case, the bending of beam will be like this one, and in this case, the deflected part of the beam will be this one. So you can see here at the joint there is zero rotation, while in this case at the joint there is a theta rotation. So in this case theta will have some definite value, but in this case a theta will be equals to 0, which means there is zero rotation. Similarly, there may be a continuous beam. So continuous beam may have n number of spans. So this becomes the continuous beam. And we may have cantilever beam. So in the cantilever beam, one end is connected, the second and the other end is free. So this classification of beam is based on the end conditions. And I just discussed the types of beam based on the location. So there are various sections which are being used in the steel beam, but majorly, if I say that the angle sections and T sections, they are generally weak in bending, and that is why generally we don't use angle sections or T sections alone. They may be used in a very light loading, but the ideal section for beam is the I section. And that is why generally the types of sections that we use in case of beam, they are generally like I section. So this I section is hot rolled I section, generally for a moderate load. Similarly, if there is a very large load, in that case what we can do is we can make this as built up beam by adding the plates to the flange. Similarly, if there is a very large, very heavy load, in that case we can design the beam as a plate girder. In that case, what we do is we add the plates by welding and in the shape of I. In other case, we can use angle sections along with the plate. So these two beams becomes the built-up beam. Similarly, in case of beam, generally we assume that, not assume that, obviously the load will come like this one, and this is basically the transverse load. But sometimes there may be a load like in this direction, and this will be a lateral load. And in that case, the beam may have torsion. So when such tendency of lateral load will be there in case of building, in case of beam, then what we do is we try to make the compression flange of the beam a little heavy or a little strong, so that because this lateral torsion will occur on the upper part of the beam. So if this is a neutral axis, so the upper part will be in the compression and the lower part will be in the tension. So basically this buckling phenomena, it generally doesn't occur in case of tension member, it occurs in case of compression. So this beam will have tension and compression both. So compression will be on the upper side, and in the compression, the beam will tend to buckle, and in that case, this lateral load will tend to rotate this beam also. I will show you this phenomena in more detail using the diagram in the next slides. But in that case, when the lateral load is also significant, in that case, what we can do is we use a wide flange beam and along with the channel section. So this is again a kind of section which can be used to resist the lateral as well as transverse load. Similarly, for the lintel beam, sometimes we can use lightweight beam, say ISJB. ISJB is the Indian Standard Junior Beam. So lightweight beam can be used as a lintel beam because lintel beam is a very light beam which generally carry a very light load, or in combination of the angle section, we can use this combination also. Similarly, when there is a headroom restriction, in that case, what we can do is we can join two channel sections and they may be separated by pipe. So this kind of configuration can also be used when there is a headroom restriction. Similarly, now the next section, this is called castellated beam. These two beams, these are the castellated beam. So basically, this is actually the castellated beam, and it is being manufactured by using the I section. So basically, there is a I section, and I section in the middle is cut in this pattern. So it is cut in this pattern, and then after removing it, it is being joined in this manner. So basically, in that case, there are some holes. So these holes may be used to accommodate the ducts. And why we do this? Because by doing this, this is being welded. This part is welded. So in that case, what happens is the modulus of section of the same I beam will be increased. So this castellated beam is used in case of a building when there is a requirement of the large span with the light loading. So with the light loading and in case of large span, the castellated beam can be used. Similarly, when there is a very heavy load and requirement of the span is also very large, in that case, we can use built up beam, and which will be in the manner of box. So this box section can be used when there is a very heavy load. Now in the table, you can see there is some range which are being given for different types of section. Like I said, that angles are generally not used in the beam, but if there is a requirement for the light loading, so in case of light load, the span of the angle can be range up to 6 meters, but again it will be for very light loading. Similarly, for a rolled I section, the span can be up to 30 meter, and this is the most frequently used section. Similarly, castellated beam, I just shown you in the previous slide. So the span of the beam can be range from 6 to 60 meter. So up to 60 meter long span can be used as a for the castellated beam. But again, it can be used for long span for the light loading. Now for the plate girder, I shown you like plates are joined in the I section manner and they are being welded. So this plate girder can be used for the span range 10 to 100 meter. So when there is a very long span and with the heavy load such as bridge girder, in that case plate girders can be used. Similarly, box girder also, as I shown you in the previous slide, you can see this one. This is the box section. So this kind of section is used up to a span of 200 meter. So box sections are used when there is a requirement for the long span, and also when there is a very heavy load, such as in case of bridge girder. So in that case also box girder can be used. So we will continue our discussion in the next part. Thank you.